What you are looking at right now are the stars orbiting the supermassive black hole at the heart of our galaxy. These so-called S-stars provided the first clues that the massive object present at the Milky Way center is indeed a black hole, since even light cannot escape the gravitational pull of a black hole. Astronomers rely on indirect ways to confirm their existence. Because of that, we have only been able to detect stellar mass black holes in binary systems by analyzing the gravitational wave signals or the electromagnetic radiation emitted when they feast on their companion stars in the system. But astronomers estimate that there could be 100 million black holes roaming in our galaxy among the stars. The problem is that we haven't been able to detect an isolated free-floating black hole in the Milky Way so far. However, following 6 years of meticulous observations, NASA's Hubble Space Telescope has, for the first time ever, provided direct evidence for a lone black hole drifting through interstellar space by a precise mass measurement of the phantom object. So, how did Hubble make this exciting discovery? How far is this rogue black hole away from us? And most importantly, why is this so critical for physics and astronomy? Stellar mass black holes form when a monstrous star, more than 20 times the mass of the Sun, collapses under its gravity at the end of its life. Because the self-detonation is not perfectly symmetrical, the black hole may get a kick and go careening through our galaxy like a blasted cannonball. Although we cannot observe the free-floating black hole directly, there is an indirect way to determine its presence. A black hole warps space, deflecting and amplifying starlight from anything that momentarily lines up exactly behind it. This phenomenon is known as gravitational microlensing. Predicted by Albert Einstein in 1936 using his general theory of relativity. It is mainly used to detect exoplanets, and more than 30,000 microlensing events have been recorded in the Milky Way so far. We also discussed gravitational lensing in the Earendel episode of the Sunday Discovery series. Ground-based and space telescopes, which monitor the brightness of millions of stars in the rich star fields towards the central bulge of our Milky Way, look for a sudden increase in their brightness when a massive object passes in their foreground. And the Hubble Space Telescope is one of the best instruments to do this job. Astronomers first noticed this microlensing event way back in August 2011. The star brightened and then faded back to its normal brightness as the black hole passed by. But how do we know that the foreground object was indeed a black hole and not a compact rogue star? There are two critical points to consider. The first is that the intense gravity of the black hole stretches the microlensing duration significantly. For example, this microlensing event lasted about 270 days. Secondly, if the fleeting object were a compact star, it would have caused a transient color change in the starlight as measured, because the light of the foreground and background stars would momentarily be blended. But no color change was seen in the black hole event. Also, Hubble measured the amount of deflection of the background star's image by the black hole. The star's image was offset from where it normally would be by about a milli-arcsecond. NASA says that equivalent to measuring the diameter of a 25-cent coin in Los Angeles, as seen from New York City. This astrometric microlensing technique provided information on the black hole's mass, distance, and velocity. Two teams used the Hubble data to arrive at slightly different conclusions. One led by Kailash Sahu of the Space Telescope Science Institute in Baltimore, Maryland, and the other by Casey Lam of University of California, Berkeley. Sahu's team reports that the black hole weighs around 7 solar masses. However, Lam's team reports a slightly lower mass range, meaning that the object may be either a neutron star or a black hole. They estimate that the mass of the invisible compact object is between 1.6 and 4.4 times that of the Sun. At the high end of this range, the object would be a black hole. At the low end, it would be a neutron star. Jessica Liu of the Berkeley team said, "As much as we would like to say it's definitely a black hole, we must report all allowed solutions. This includes both lower mass black holes and possibly even a neutron star. Whatever it is, the object is the first dark stellar remnant discovered wandering through the galaxy, unaccompanied by another star." The observations were difficult to make because of a relatively bright star in the vicinity of the lens star. The team said it was like measuring a tiny motion of a firefly next to a bright light bulb. They had to meticulously subtract the light from the nearby bright star to precisely measure the deflection of the faint source. The black hole is traveling across the galaxy at 100,000 miles per hour, or 160,000 kilometers per hour. That's faster than most of other neighboring stars in that region of our galaxy. It lies roughly 5,000 light-years away in the Carina-Sagittarius spiral arm of our galaxy. The discovery has also allowed astronomers to estimate that the nearest isolated stellar mass black hole to Earth might be as close as 80 light-years away. That's nearly 20 times the distance to the Sun's nearest stellar neighbor, Proxima Centauri. While detecting these rogue black holes will provide new insights into the population of these exotic objects in our galaxy, finding them is like searching for a needle in a haystack. Astronomers believe that only 1 in a few hundred microlensing events are caused by isolated black holes. However, NASA's upcoming Nancy Grace Roman Space Telescope will discover several thousand microlensing events, out of which many are expected to be black holes. Furthermore, the deflections will be measured with very high accuracy. The Roman Space Telescope is an infrared telescope currently in development and scheduled to launch no later than May 2027. Surely, some exciting astronomical discoveries are on their way. If you can operate the Hubble Space Telescope for a day, where would you point it in the universe? Let's see who has got the most interesting choice. Also, if you enjoyed this video, make sure to like it and subscribe to our channel for more episodes of the Sunday Discovery series.